Okay, so now we're going to talk about sector area. Now, a sector is basically a slice of pizza or a slice of pie. How big is that slice of pizza, or how big is that slice of pie? When we're talking arc length, we're talking about just the crust on our pizza or pie. Okay, but when we're talking sector area, we want to know how big that whole stinking piece of pie or piece of pizza is. So a sector is a portion of a circle bounded by a central angle and its intercepted arc. So there's our central angle and there's our arc. A sector is like a slice of pizza or a slice of pie. The area is a portion of the entire area of a circle. So if you'll remember, area is pi r squared. And so we can call our sector area as x out of 360, just like the arc length was a portion of the circumference. The sector area is the portion of the area of the entire circle. And lucky for you, this part is super easy because we've got all of our, they gave us radii for almost everything. So this one here, BC is 16 feet. So our R is 16. So we are going to have, and they told us that our angle there is 51. So our measure of our arc is 51. So we're going to have 51 out of 360 times 16 squared pi. Okay. So now when we go into Desmos and we put in our fraction, 51 divided by 360. The way that you get your squared is by pressing that a squared button right there. So we're going to multiply this by 16 squared. And notice we got a pretty large number with a decimal, so we're going to put that into fraction form, and it's 544 over 15. And that's all, peeps. So this in there is 544 over 15 pi, and there is our sector area. So now number 2. Our arc measure is 139 out of 360. PQ is 22, so that's our R. And we're going to multiply that by 22 squared. Throw our pi on the end. This goes into Desmos. Ooh, we're getting really low here. 139 out of 360 times 22 squared. Put that in fraction mode, and we get 8,228 over 45. So 8,228 over 45. Pi is still hanging out there, and we're done. So on this one, JK is 3. So our radius is 3 here. Intercepted arc is 84. So 84 out of 360 times 3 squared pi. This is going into our calculator. 84 out of 360 times 3 squared gives us 21 over 10. You can see it. Let me pull Desmos back up there. You can see it down there on number 9. So 21 over 10. Pi stays there. Final answer. Okay, number 4. GH is 13. Now, they did something a little tricky. They gave us the measure of this arc. Well, we don't need we don't want the measure of that arc. We need the measure of this arc. So the way that we're going to get there is we're going to do 360 minus 126, and that's going to give us 234. So we're going to do 234 out of 360 times 13 squared pi. 234 out of 360. 234 out of 360 times 13 squared. And when we get this fraction, just wait for it, 2197 over 20. Pi is always there. And that's our final answer. Number 5, we got to do the same way. YZ is 9, so that's our R. We're going to have to do 360 minus 42. When we do that, we get 318 degrees. So we do 318 out of 360 times 9 squared pi. $318, 360, 9 squared. And for this one, oh, whoops, I put 361. Let's fix that. I was like, well, that's an awful number, but that's because 361 is not 360. Now look, 1431 over 20. Not much better, but a little. 1431 over 20, pi, and that's it. And then finally, we're ending up here with an easy one. 28, our central angle is 115, so our arc is 115. So we're going to do 115 over 360 times 28 squared. Get it in fraction form, 2254 over 9. We need our pi, always and forever, and there's our final answer. I just realized I circled the whole thing for this one, so that's our final answer there. So once you know how to do an arc length, sector area is not much different. You do need to make sure you know the radius, so if for some reason they give you the diameter, you're going to have to divide it into 2. But overall, not